Hello, ladies and gentlemen. I'd like to welcome you to today's Dynamics 365 Tech Talk. Our topic today is Finance and Operations Development ALM. My name is Peggy and I'll be your moderator today. We're broadcasting this web conference through Teams live events, and the audio can be heard through your PC speakers. Today's web conference is being recorded on behalf of the Microsoft Corporation. Participation in the meeting today indicates your consent to being included in the meeting recording. Access to the web conference recording and all session materials will be delivered by email within 5 days post-conference. If you have questions for the presenters or need support, you can turn on the Q&A panel by selecting the question mark icon located in the upper right-hand corner of your screen. We have moderators standing by to answer your questions during today's presentation, and there will be time at the end for any further questions. Presenting for us today from Microsoft is Eric Pigors, Senior R&D Solution Architect. Welcome, Eric. You now have the floor.
Thank you, Peggy. And let's get started on application lifecycle management. We have 4 chapters today. And the first is business process focus. So we want to make sure that we model our business processes in the business process modeler, and then we will sync those with Microsoft Azure DevOps or DevOps and use those to associate various work items with requirements and business processes. And remember that work items include bugs, tasks, backlog items, tests, documents, etc. The phases of application lifecycle management are at the top: develop, build, and deploy. And in the develop phase, we use development VMs to write source code and put it into Azure DevOps, and a development machine will also pull the source code out of DevOps when you create a new development machine or from other developers. During the build phase, the build VM will take the source code out of DevOps, build it, create a deployable package, which can be put into the LCS shared asset library, And during the deploy phase, the deployable package can be installed on a sandbox or UAT environment, tested. Once its testing is complete, it can be marked as a release candidate and installed on production. The first part we want to talk about is version control. The primary purpose for version control is storing the source code. This includes customizations and ISV products with source code. Source code for finance and operations is primarily in the XML text files that make up the application object tree, or AOT. Binary artifacts from ISV products without source code are also added to version control. An Azure DevOps account is free, and a free account includes 5 basic licenses that allow access to the code. And in this case, basic is the type of the license. MSDN Visual Studio subscribers, they get code access in DevOps for free without you. Yep.
Should the screens be changing? Have you moved to another slide yet?
Yes, I have. Give me one. Okay. I'll reshare here.
Thank you.
Does that look better? Oh, yep.
Yes, thank you so much.
Yep, sorry about that. Let's see here. The ALM phases are, I'll recover these. The ALM phases for develop include the development VMs putting code into and getting code out of DevOps. The build phase includes the build VM getting source code out of DevOps and putting the deployable package into the LCS asset library. And the deploy phase includes installing the deployable package on UAT, marking it as a release candidate, and installing it on production. Okay. Yeah, so I think that this is fine. MSDN and Visual Studio subscribers get code access without using a basic license, so you still have 5 available for other people. You can purchase additional basic licenses in the Azure portal, and a DevOps account includes unlimited stakeholder licenses that have access to the work items. The finance and operations usage of DevOps is standard, so all the documentation and reference material are applicable. There is one thing that is unique, and that is that the LCS code upgrade uses the trunk main branch of Azure DevOps as input, and the output is put in a new branch under the releases folder, and the releases, the new branch is named for the target version of the code upgrade and the date to make it unique. The code upgrade is primarily used, now that we're on one version, is primarily used for AX 2012 code upgrades, so it's still applicable. Do have the owner of the intellectual property own the DevOps account, and we recommend that the customer own the intellectual property and therefore the DevOps account. Do connect your DevOps account to the owner's Azure Active Directory for authentication. That link will also allow you to use their Azure subscription to purchase additional DevOps basic licenses or other licenses as needed. And when Visual Studio Team Services was renamed to Azure DevOps, there was a URL change, and the DevOps URL is more common now, but the VSTS format still works. And when you enter the DevOps URL in LCS, you need to use the VSTS format. Let's consider the minimum branching option, which is a single branch called main. The check-in, testing in the tier 2, and deploying to production all happen in that branch. And any changes, since there's only one branch, any changes that fail validation have to either be removed or fixed before retesting in the tier 2. And not just in this model, but in any model, consider that everything in a branch will be included in that branch. There's no way to exclude something, which means that you need another branch typically to be able to exclude something. Labels can be used to exclude changes from a build in a way that is similar to having another branch. The preferred branching option is to have 3 branches, a dev branch for developer check-in and testing with development data, a test branch for deploying to the tier 2 environment and testing with current production data, and a release branch for retesting in the tier 2 plus and deploying to production. We often have another branch similar to release if there's another phase of the project going on that we want to keep changes separate from production until the go live of that phase. In this diagram, the arrows show the direction when creating the branch, not the direction of code flow. Considering the movement of code flow between the branches, as I said, the code goes from the dev branch to the test branch, and from the test branch to the release branches. Let's talk a little bit about the dev branch. This is where you map your development machines. You can use the shelve or suspend commands to keep the work safe, such as when you, at the end of the day, if you're not ready to check in, you can use that to make a backup of them. It's very easy. You can also use a code reviews in Visual Studio to ensure quality, and I highly recommend doing this. Not only does it improve the code quality, but it improves the learning for your developers over time. When the features are complete, you check them into the dev branch, check in all features when they're complete and when they've had their development testing done. Do remember to only include the changes from one feature in each change set. and consider the cost of a bad check-in when determining the build trigger. And we'll talk about the build triggers in a little bit. So the flow is the developer checks in code. We do a build to make sure that the branch, it compiles, but we don't really use the build for anything else. For the test branch, we merge features manually from the dev branch that are ready for testing on production data. And we want to merge each feature in a separate change set for the same reason. If we merge two features in and one of them passes validation and one of them doesn't, we want to be able to merge only one of them to the release branch, and we can't do that if they're in the same change set. In general, you should not map development machines to the test branch, at least not to the packages folder on the development machine. You do need to map the test branch on a development machine to a temp folder in order to do merging. The release branch is a similar pattern to the test branch. You merge features from the test branch that have passed validation into the release branch. You merge each feature in a separate change set, and you start the builds manually. And then you can install them on the sandbox to retest that specific package. And if it passes, you can mark it as a release candidate and install it in production. The pattern for the release sub branch, such as for a new phase of a project, is the same as the release branch, but you have a pre-production environment instead of production. Some of the anti-patterns, just to recap them, is don't check code directly into the test or release branches. Don't check in changes for more than one feature in a single change set. Do not mark deployable packages from the dev or test branches as release candidates or install them in production. If you don't mark them as release candidates, you won't be able to install them. And do not merge untested features into the release branch. Put them in the test branch, test them, only merge them to release after they pass testing. Now we'll move on to the development phase. First, we're going to cover a little bit about packages and models quickly. A package is a compilation and deployment unit of one or more models. Including multiple models in the same package is no longer a common scenario. It was previously used for overlaying, and it can be done without overlaying. It's just less common. It is still supported. The important thing about a package is that it includes metadata, assemblies, and other resources, not source code. You can think of a package as application suite.dll to get it, one or more packages can be included in a deployable package, which is what is used for deployment on runtime environments. So to install the packages, we use a deployable package. A package can also be referred to as a module, not a model, but a module. And a package has a top level folder in the metadata folder in version control, and it also has a top level folder in the packages local directory on the development machine. So you can see here that in the packages local directory, application suite is one of the packages. In an asset library or in a deployable package, the packages are listed as modules. In this case, the app extension APP-EXT module is a package, and this deployable package only contains one package. A model is this group of source elements such as metadata and source files that make up a distributable software solution. A model is a design time concept that contains source code. The key to a model is its descriptor file. A model has a folder in the package folder of the packages folder. So in the example before, application suite was the package, and in this case, foundation is the model. The descriptor is stored in the descriptor folder of the packages folder. So application suite, descriptor, and then the application suite descriptor folder, the foundation file is the descriptor file. And this is in the Windows Explorer, the models are inside the package, and the model folder contains all the normal AOT items, classes, EDTs, all those things, the normal standard folders for source code. The day in the life of a developer is something like this. They RDP to the development machine. They perform a get latest on version control, which copies all the code from version control down to that development machine, whether it's a new development machine or they're just picking up the changes from the other developers since the last time they did it. Then they work on their features, including they can run a build on that development machine and collaborate with business users to test the features using the development VM's website, and you have to RDP to a VHD to use that machine's website, but otherwise it's the same. When their feature is complete, they check it into version control. And the general idea is that it's quick and easy to get a new development machine or to get a new developer up and running. It does not take that long. You just have to download the customizations and you're ready to start. For a new development machine, if it's a VHD, you have to run the admin provisioning tool. After that, you need to sign into Visual Studio with the account for that contains your VS license. If you don't have a license, you can get a 30-day trial, but you will need a license. You're not able to open Visual Studio if you don't have a license or a trial license. Then you can connect Visual Studio to version control, and you can use a different account than the account used for the VS license. It's pretty common to have a partner developer use their partner email for their VS license, but use a customer email to connect to version control because we recommend that the DevOps account be owned by the customer and it be connected to their Azure Active Directory. Then you map the version control folders to the local machine, and the machine is ready for development. This is a picture of the mappings for a development machine, and you can see that this maps the dev branch to the development machine, which is what we recommend. And the dev metadata folder is mapped to the packages local directory. The projects folder is mapped to the local Visual Studio 2015 projects folder. And this machine has main mapped to a temp folder for doing merging. Make sure that each developer has their own DevOps license and login. That ensures good traceability. They also need to have their own development VM and Visual Studio license. Again, sharing a development machine, they would end up sharing DevOps logins, and that would not allow for traceability. Do reference a feature work item with each check-in, and Visual Studio has features to do that, so we recommend using that. Consider writing automated tests using the sys-test framework. These are more of unit tests, and they can be run during the build. Also consider using test-driven development techniques. A couple of other things is you should treat a development environment as disposable, meaning that you should make backups of what you're working on, but Visual Studio has shelve and some suspend options through DevOps to keep your work safe if it's not ready to be checked in, and we encourage using those. Development machines do occasionally fail, and so you don't want to be losing work because of that. Consider that the service update on a development machine is not that critical. We'll talk about this a little bit more, but you don't really need to update your development machine service update that often if you don't want to. There are some cases where you may need to. And one exception is that if you want to copy a production database through its sandbox and get it down to your development machine, they do need to be on the same version or greater than production, which it is certainly done. It's not as common, but people do put production data on their development machines in some cases. Also consider non-functional requirements such as performance. Implementing more performance than is necessary will just take longer on the development work, and implementing less performance will typically result in rework, which will also take longer. Consider a data entity. If it's going to need high performance, implementing it as a set-based entity right away is the correct thing to do. If the performance is not needed, doing that will take longer than is needed. And if you have to change it to be set-based, it'll just take even longer because you implemented it twice, basically. For ISV products, you check the source code, you install the ISV product on the development machine, and then you check the source code into version control if you don't have the binary deployable package from the ISV. If you do have a binary deployable package, you install that on the dev machine and check the binaries into version control. The build machine will copy those binaries straight into the deployable package in that scenario. You can install the source code on development machines as needed, even if you're using a binary deployable package for the runtime environments. The scenarios for doing that are debugging the ISV solution and customizing the ISV solution. Let's cover a few of the things you should not do in development one more time. Don't let developers hold their changes on a development machine without backing them up using the shelve or suspend. Do not let multiple developers use a single development machine or share DevOps logins. And don't check in changes for multiple features in a single check-in or change set. And don't use Visual Studio to create deployable packages. We'll talk more about that in the build section. This topic on builds refers to automated builds using a build machine. Of course, dev machines do builds as well, but we're talking about the ones done on a build machine. And in any case, a build is the process of taking the source code and producing binary files that a system can run. No code can ever run without performing a build first. And this includes the database sync for finance and operations because it retrieves the schema for the tables from the assemblies and not from the XML source files. And we mention these things about the build because in X 2012, the build was sort of taken for granted a bit because every environment was able to do a build, including production. And in finance and operations, only the development and build machines can perform builds. An automated builds serves a few purposes. They make sure that the code compiles without errors in the dev branch, and they also perform automated testings such as unit tests and sys tests after a build. It creates a deployable package which is suitable for sandbox and production runtime environments. And it's a way to create a single deployable package that contains all of your packages. And the reason we recommend that is because installing more than one deployable package in a single downtime or night should not be necessary and it takes longer because of the lead time to install a package on production. Builds can be started manually or automatically, and the other great thing about using a build machine is developer isolation. The build machine is a clean environment. It doesn't have anything extra on it. It only takes the code out of DevOps, which gives you consistency, whereas a development machine might have some extra code sitting on it that was not checked in, but because it's on that machine, when you do a build, it would be included on a development machine. That is not the case on a build machine. You need to make sure that the service update on the build machine is less than or equal to production. This is standard finance and operations backward compatibility at runtime. We guarantee backward compatibility at runtime only. And doing this can be achieved by installing a new service update on the build machine last, or at least after production, or not at all. It's not critical that the build machine or the development machines be updated with a new service update in most cases. Let's talk about this example where we check in some code to version control that uses class or table named D, which was new, and if the build class or table D was new in version N+1. It does not exist in version N, and if you check in that code and run a build, the build will fail. And even though it's a failure, that's the preferred option here. So that's our happy path. And then because the other scenario is that if you check in that code using D and your build machine has been updated and it's newer, it has a newer version than production, the build will succeed and then it will fail being deployed to production because production does not have code that knows about D yet. And so in this case, the failure of the build is a much better option than the failure of deployment on production. The builds in DevOps have triggers for builds, and that's just different ways of starting a build. You can schedule them, so you can run a build every night at 6 o'clock or something like that. That could be a simple model for development. Continuous integration means that a build is started as soon as a check-in is done. Gated check-in takes that a step further, and it starts a build when the check-in is attempted, and it only commits the check-in if the build succeeds. And then you can also start a build manually from the Azure DevOps website. Let's talk about the dev branch on a build and build machines. Schedule an automated build at least daily. The most common scenario for why you need a build is that on the dev branch is that if the developer forgot to check in something is the most likely. There can also be conflicts, but it's much more common that they forget to check in something. It will build on the development machine, but it will not build on the build machine. And you should consider using the continuous integration or gated check-in build triggers. Typically, the more developers you have, then those start to make more sense. The purpose of the dev branch builds is to verify the code. The deployable packages that result from those builds should not be installed on any environments. On the test branch, since the changes are merged manually into the test branch, typically the builds are started manually, but that's not a requirement. Install the deployable package from the test branch on a tier 2 environment for testing using recent production data. But do not mark the deployable packages from the test branch as a release candidate because we have no intention of installing them on production. The release branch is similar. You start the builds manually because things are merged from the test branch manually. You install the deployable package on a tier 2 environment for testing using recent production data. And when they pass validation, you mark the deployable package as a release candidate so that it can be installed on production. Make sure that you test the deployable packages from the release branch, even if the same features were tested in the test branch build, because the release branch and the test branch are likely not the same. The alternate release branch is similar pattern to the release branch, except that you would not mark them as a release candidate because they're probably not going to production. They're probably going to some pre-production sort of environment. A few notes on the build machine. You need to have one build machine for each application version before one version at least. There are some scenarios like we talked about with service updates where you might need multiple build machines, but in general the builds are backward compatible and that normally works with just one build machine. Azure DevOps has build definitions. I believe that they're called pipelines now actually, but you can have a build definition or pipeline for each branch and build trigger that you need. So if you have a gated check-in for your dev machine or your dev branch, you'll have a build definition. If you have one that runs every night at 5 o'clock, you'll have another build definition for dev branch, etc. We recommend that you use consistent naming for your deployable packages, such as the name of the customer's company, what branch it came from, and the DevOps build number for traceability. And then it's a good idea for traceability and consistency. It's a good idea to put something more meaningful to people in the description, such as the bug or KB number that sort of was the reason for creating that build in the first place. But keeping the names consistent is recommended. Some anti-patterns for the build machine is you should not RDP onto the build machine. All the normal things that you need to do can be done from the Azure DevOps website, and there are maybe a few edge cases where you would want to RDP to the build machine, maybe to free up some disk space or something like that. So you should never open Visual Studio or map it to the branch in version control. That's all handled automatically by the builds, and you never use Visual Studio to create a deployable package instead of a build machine. As I mentioned before, the deployable package will contain all the code on that development machine, whether it was checked in or not, and that is not good for consistency either. This is an example of two deployable packages that from back before one version that were created, and the one on the right was created with Visual Studio, and it doesn't include the directory module, sorry, and that's because the directory module was there due to a KB, and so when you install this Visual Studio build on an environment, you'll get whatever directory is already on there, and that could be cause some problems with consistency. All right, let's talk about some deployment items. The manual deployment is to download the deployable package from Azure DevOps, upload it to the LCS asset library, and then install it on an environment. And now we also have automated deployment for non-production with Azure pipelines. Go through the manual steps first. The UI changes a bit from time to time, so but this is what it is currently anyway. So you go to, in Azure DevOps, you go to pipelines, under pipelines, and then you click on the pipeline, which is used to be called build definitions. That will show you a list of the recent builds, so you can click on the build you want. And when you get to the build, there will be an artifacts. You can click on that. And that will show you the logs and other things, which is the logs are good if the build failed. That's where the information about why it failed. But what we're interested in is a successful build. You expand to the packages node, and you'll typically see two items. One that begins with AX deployable runtime, and the key there is the runtime. That is the deployable package that contains all the assemblies. And the other one is the AX model source, which is all the source code. It's a snapshot of what was of the Azure DevOps source code that's in this build, which can be useful for looking at things as well. But typically the runtime is what we are after now. From there, you add when you click on the deployable runtime, it'll download. From there, you go to the asset library to create a new deployable package. You give it a name. So in this case, I named it, again, based on the customer name, and then the branch, and I gave it the date from Azure DevOps build number. And then in the description, I put the official DevOps build number, and then I note that we ran this build for a KB reason. So you add all that and add the file, and you select the deployable package you downloaded in the last step, and then you confirm, and that'll create the asset library, put it in the asset library. And when you go to the environment in LCS, you could click on maintain and apply updates. The list from the asset library shows up, and you select your deployable package, and it will start installing. For the build pipeline and release pipeline, the automated ones, the build is queued, and it doesn't really matter if it's a manual or scheduled or triggered. When the build completes, then the release is queued in the same way, and that completes it. And you do want to clean up your old released assets from the asset library. One edge case, but it does need to be done sometimes, is uninstalling a module or a package. And this could be a case where you have been using an ISV and you decide to stop using them or something similar. So the first thing you need to do is update all your packages that will remain to not reference the one that's going to be removed. Visual Studio has a model dependencies view to show you the references. So you need to clean up and remove all the references to whatever is going to be uninstalled. Then we recommend that you update the model. You update the module to be uninstalled with all code removed. So you take all the code out of the model except one class, you build it, then you deploy that small, and it doesn't reference anything itself. And then the final step is to follow the documentation instructions. You create a text file and you put it in the deployable package, and the text file contains the name of the module to be removed. And then you install that deployable package and it will remove it. But the first thing to do is make sure it's not used by any of the code that's still there. Do strive for 100% automated ALM. We've come a long ways in this aspect, and there are automated steps in DevOps to update the model versions, to create a deployable package, to add a license file to a deployable package, to upload the deployable package to an asset library, and to deploy the deployable package to non-production environments. And the finance and operations tools is available in the Visual Studio Marketplace. for Azure DevOps. This is what supports the automated ALM, and it's implemented as the build and release pipeline tasks. Volker, are there any questions?
Yeah, we received quite a lot of questions. We're still in the middle of answering them. But let's look into some of them. So one interesting one came from Sander, and he asked if there's any time frame on the support for building and releasing on Microsoft hosted agents instead of the dedicated build environment we have today.
There is it is being worked on, but at this time I don't think we have ETA. It's not in the release plan at this time, but it is something that we are working on.
Great. So the next question I would like to point out is about whether the branching strategy you talked about is applicable for both Git and the Team Foundation version control.
Right. So Git is not officially supported, although my understanding is that it does work and that there are some MVPs or blogs about it, but it's not officially supported, but my understanding is that it does work.
Great. Yeah, there were a couple more questions around that area and about official support. But yeah, thanks for that.
Sure. Yeah, I have not heard of any immediate plans for official support.
I think the answer to that might be it might not be officially supported at any time because, well, we strive to give you the ability to use whatever you want and not block you from a tooling perspective. So that's more of the direction everything goes. Not to have tooling in place that disallows you from using Git or any other. So that's the goal we have, I would say. So the next question that might be of interest is around Visual Studio versions. Still, we're in 2015. Is there any plans for going for later versions?
Yeah, it's not in the release plan yet, but I believe that I have seen demos and things using newer versions, so I think it's eventually going to come, but it's not. You have to watch the release plan for the official info, but I think that that's a good point.
Okay, thanks. Someone pointed out that they would have a lot of developers and asked if it's really necessary to have a development machine for each and every one of them.
Sure. Today it is. That's the recommendation. We are working on some things to address that specific problem, but there's no ETA at this time. But I think that there have been demos and stuff in some cases, but it's not official. It's not in the release plan yet, but it's being worked on.
All right. And maybe the last question we can cover is around the branching strategy. So the question basically was the branching strategy you described in the presentation. How would then emergency production issues be fixed? And whether there needs to be a special release branch and, well, at the same time, there's additional work being done on one of these branches.
Yeah, I mean, if you've already have features being tested in the release branch, like we said early in the presentation, there's no way to exclude code from a build. If it's in the branch, it'll be in the build. So there aren't any simple solutions there. Obviously, if the code is in the release branch, it's pretty far along, and it might make sense to just to put the KB in and continue with the testing. It is possible to roll back what was put into the release branch. That would be an option as well, if that makes sense. I think that a lot of people ask questions like this, and they're good questions and they're valid. But I think that getting in a hurry is not a good idea. Typically, taking some time to think things through would be is a much better approach, and a lot of times a good solution is is easier to come by when you just take a step back and don't rush. But it is version control, so you would be able to roll back what's in test already if you want to just to go forward with a new release build that only has this KB since the last one was done. That's one option.
Great. I think we still have some time, so we can tackle maybe a couple of more questions.
Yeah, certainly.
The next one would be when automated deployments are supported for self-service environments.
I believe that's also planned, but it has not been announced yet. But that's going to be a very common, self-service deployments are going to be very common, so it has to be supported, and we will support it. Great.
Yeah. Soon is the answer.
Yeah, I think soon. Yeah, I think
it's soon. There was another question around Git and if it's supported instead of Team Foundation version control.
It's not officially supported, but like I said, there's a good amount of community knowledge about it, and I know that, and what I've heard is that Team Foundation version control is just simpler, and Git can, if you're not experienced, or even if you are fairly experienced, it can be tricky at times. But it's not officially supported, but I think there's good community support for it if you're, if that's what you want to do.
Okay. Someone's asking about LCS upload tasks and pipelines. Can you elaborate on that a little bit?
We have LCS upload tasks, right?
Yes,
I'm not sure what
we have that
is.
available. It was part of, yeah, true. So it didn't have like too much of context.
Okay, well, so one thing is, I know the reason that I'm not over familiar with it is because it does not support multi-factor authentication. So there are some limits like that to it, and I think that we are working on a way to get around that, although that is largely a function of the Azure Active Directory that is in use there. So the Microsoft.com Azure Active Directory that I use obviously has multi-factor turned on. So, but otherwise, that's the only limit that I really know of.
Yep. So let's tackle one last one. We'll try to answer some in the chat then over the next couple of minutes, which were not answered yet. The last one we can take here is, where can partners or customers see the official Microsoft release plan that you have mentioned for these new features? And I believe that refers to things like getting rid of dev machines and so on and so on.
Yeah, those would be in the standard release plans that come out, and I believe that if you go to dynamics.com, the release plans are in one of the menus at the top. But if you search for the release plan, it should come up. They're readily available. And there's like a there's a docs article, and then there's a PDF that is quite large, and where everything that is in the plan is documented. Okay. Any other questions, Volker, that you can think of?
Yes, I said there are a couple more in the Q&A, but let's end it here.
Okay, we'll answer those online. Yep.
Yeah, if the audience would like to stay online, the presenters will be answering questions in the live Q&A area. But in the meantime, if I could please ask you to note the link that I've just posted there in the chat window. This will allow you to take a short survey and let us know what you thought of the presentation today. We greatly appreciate your time in taking that. The survey scores on a scale from 1 to 5, with 5 being the highest score possible. And as a reminder, all attendees will receive a link to the recording and all session materials via email within 5 business days post-conference. So this does conclude the live version or the live portion of our event today. So again, feel free to stay online and ask questions. Thanks so much. Have a great day or evening wherever you are.